Welcome to the 3D modeling part of these AutoCAD video tutorials. Let us first try to understand the distinction between 2D and 3D modeling. 2D models are the flat orthographic representations that we are accustomed to creating with front, plan, and end elevations. 3D modeling, on the other hand, is a mathematical and graphical representation of a three-dimensional object using a collection of points in 3D space, connected by various geometrical entities such as triangles, lines, curved surfaces, etc. 3D objects are, in general, easier to visualize since they show how the object actually looks using rendered computer graphics. Take a look at this 3D object here. In this area of the View panel on the Home tab, we can alter how our 3D object is rendered. The two that we use most often are the 2D wireframe for a skeletal outline representation and the conceptual view for a shaded, more solid rendering of the object. This icon here is called the View Cube, and we can use it to manipulate our view of the object being created. It is very important to note at this point that by pressing Shift on the keyboard with your left hand and the middle wheel button on the mouse with your right hand simultaneously, we can manually rotate our view of the object. Let's start a new drawing and take a look at our AutoCAD 3D environment. Using this flyout here from this spur gear shaped icon, we can switch between 2D drafting and annotation and 3D modeling. We use 3D modeling and not 3D basics because we have more tools available in the 3D modeling workspace. We can use the grid display toggle switch on the status bar to either display or remove the grid from view. Look in this area here of the Home tab interface. We can see the shapes box, cylinder, cone, sphere, pyramid, wedge, and torus. We call these shapes simple primitives, and we can combine these primitives to help us create more complex geometry. Now, look at these solid editing functions here in this panel. They are called solid union, solid subtract, and solid intersect. We call these functions solid editing Boolean functions, and we use them to help us combine the simple primitives into more complex geometry. Let us start by creating a box. Simply click on Box and the AutoCAD command line will ask for us to specify a point for the first corner. Then enter L. Now we can enter the length of the box as 100 mm, the width as 50 mm, and the height as 75 mm. There is the box. Now we can create a wedge using the wedge command. Simply click on wedge from the panel, specify our first corner and enter L for length. We can now put the length of the wedge as 20 mm, the width as 50 mm, and height as 25. We can now orient the wedge the proper way we want it using the 3D rotate command. Then we can insert the wedge into the box like this using the move command and our midpoint object snap. Let us now use the subtract command to subtract the wedge from the box. Simply click on the subtract icon and we firstly select the object we want to subtract from, which in this case is the box, and then hit enter. Then we select the object that we want to subtract, which is the wedge. When we hit enter, the wedge is subtracted from the box and we end up with this shape. Let us now create a hole at the top of the box. We start by clicking on the cylinder icon and selecting a point for the base of our cylinder. Then we can enter the radius of the cylinder as 5 mm and the height as 25 mm. With the cylinder created, we can now insert it into the box like this via the move command and making full use of our object snaps. Let us now subtract the cylinder just as we did with the wedge a moment ago. Simply click on the subtract command and choose the box first and the cylinder second. When we hit the enter button, the hole is made. Let's take a look at it in conceptual mode. Finally, we will create a bolt to insert into the hole at the top of the box. Let us start the bolt by firstly creating the hexagonal head by drawing a hexagon using the polygon command. We enter 6 for the number of sides, I for inscribed, and 20 mm for the radius of the circle. Now we can use the press pull command by clicking on the press pull icon in the modeling panel of the Home tab to extrude the hexagon upwards by 5 mm. In order to extrude with the press pull command, all we have to do is left click within an enclosed boundary. Press pull is one of the most powerful and important tools we would be using in 3D AutoCAD, therefore getting familiar with it is paramount. We can virtually create any two-dimensional profile using lines, arcs, circles, etc. and then extrude with press pull. For example, we can do a random profile using lines and circle and then trimming. We can then use the press pull command to extrude this completely random shape, with the only constraint being that the profile must be completely enclosed with no open gaps. Let us now create the length of the bolt by using a circle drawn onto the top face of the hexagonal head. The circle's radius is 5. Ensure that the dynamic UCS is switched on in the status bar so that we can draw the circle on the correct face. We can make use of object snap tracking to help us get a focus on the center point of the polygon, or we can draw a line for a guide. The next step is to press pull the circle upwards. There we have a 3D representation of our bolt. Let us union the bolt's head and thread section to make the bolt one complete entity. We can now rotate the bolt to the correct orientation using 3D rotate, and then we can move it into place at the top of the box using the move command. Here is our finished design. We can look at it in conceptual mode. Or we can look at it in shades of gray mode. "3D modeling can be a useful graphical tool in helping us visualize our designs. Primitives can be combined to form more complex geometry, or we can simply draw closed profiles in the XY plane and extrude them using the press pull command. Thanks for watching, and start practicing your 3D design.